everyone, and welcome to the Partner Innovation video. I'm Alina, your host, Principal Program Manager at Microsoft in Smart Places and Energy team. And today I'm here with Rick Skodronsky, Willow's Director of Product Management for the Willow platform. And we are going to talk about digital twins. Rick and I have been working on digital twins for the last 5 years. And real estate solutions and digital twins have been my passion for a while. About 2 years back, we've shipped Azure Digital Twin service, and Willow was the release partner. So there is long history behind today's topic. Rick, it's been great to have you here. May I ask to introduce yourself and share a little of what Willow does?
Thanks, Alina. Yeah, really glad to be back with you here talking about what we love, which is all the great technology we're able to build on top of Azure. Willow is a technology company that creates digital twins of real assets, such as infrastructure, like rail, real estate, aviation, and mining. And we enable our users to make proactive data-led decisions in real time to help improve their business. Our mission is to modernize and transform the built world. And we've got kind of 3 core values in terms of improving sustainability, performance, and connectedness. So we've been partnering closely with Microsoft since the inception of our company, and leveraging all the great technologies that I mentioned, such as Azure Digital Twins, and a lot of the IoT services such as Edge and Hub.
Rick, it's been a privilege to work together throughout all of this time. Could you share a little bit more about the technical value of our partnership to our customers?
Yeah, absolutely. So I always like to start with the graph, with Azure Digital Twins, because that really is the core of our WillowTwin solution. And what we're showing here is we have all sorts of data sources coming into to the WillowTwin. These could be static data sources, such as system or device data. They could be live data sources or telemetry coming in from sensors, which get ingested through our IoT Hub pipeline. All of those enter the twin, and we are able to drive powerful outcomes leveraging that knowledge graph, which we can then see on the right, such as improved space utilization, a better occupant experience. We can drive reducing energy, reporting on sustainability, and really monetize that data to drive experiences that we're really passionate about. Once we have that powerful foundation in place, we're able to traverse the graph and the relationships that we have put in place. And so what's great about this is it's a common data model, it's a common infrastructure that can then lead to many outcomes. So rather than having to create bespoke data models and kind of relationships to produce a certain outcome, we're able to use that kind of core foundation with the ontology, leveraging digital twin definition language in Azure Digital Twins.
It's great to hear how Willow has been able to build value for our customers with all of these services, Azure Digital Twins, Real Estate Core Ontology, and many more services. Could we see how all of these services come together in your offering?
Yeah, let's just take a quick look at our architecture diagram, which starting on the left here, we've got the edge. And so that's where we're running the IoT Edge runtime, which can run on a various different form factors. So it could be a small form factor trust box where we deploy a dedicated IoT Edge runtime, and then really deploy what we call our connectors. And those are edge containers that connect into different third-party systems. It could be a serial network such as BMS, Modbus, BACnet, Modbus, or OPC, or it could be just another vendor's API-based edge service. It could be a box that has more compute, more storage, such as an Azure Stack Edge, or it could be a virtual machine. Regardless, we're connecting into that data, and it ultimately flows into our solution through the IoT Hub. And at that point, it hits our ingestion pipeline. And first and foremost, it enters the twin, gets historized in Azure Data Explorer, which is our high-speed, high-capacity telemetry storage service. And it also hits our rules engine, which I think we'll touch on a little later, to be able to drive actionable outcomes live in real time with the data. And we do other things such as ETL the data into Snowflake and drive different business intelligence outcomes. So all sorts of different types of analytics that happen once the data enters our platform. But again, I like to draw attention to the shining star in the middle, which is Azure Digital Twins.
Well, thanks. Let's talk a little bit about cybersecurity. This is an important aspect of digital twins. And I'm saying because industries have been implemented digital twins, right, to protect and monitor their assets. And there are some companies like Willow that have taken the leap to bring their cybersecurity to the next level with faster speed and precision to prevent and combat all of these potential threats. How does Willow think about cybersecurity all the way from device to the cloud?
Yeah, cybersecurity it's really important to our entire business, not just the products that we build, but just how we run our business. We take it very seriously. So we actually have an entire cybersecurity team focused on this, and so we're very proud of our ISO 27001 certification and our SOC 2 certifications. These are certifications that show how serious we are, and what we've done is leveraged all the great security that Microsoft Azure PaaS services have in place, and made sure that we've gone through the appropriate steps to get those tested and put together. So things like our Edge solution in partnership with our Edge provider Scalus that provides that trust box, ensures that we've got a secure connection from the edge to the cloud, and we're able to deploy updates to our containers running on those edges centrally and push those down in a secure fashion. And so all of our telemetry that streams from the edge to the cloud is secure. And then all of our cloud infrastructure is secured by all the great Azure services that we have.
This is great to hear. Another topic, let's switch gears a little bit towards sustainability. Reducing carbon footprint, energy optimization, these are top of minds for many. And again, I'm curious to find how WillowTwin support people on their sustainability journey.
Yeah, that's as you saw from our mission statement slide, sustainability is one of the three pillars of our company that we're looking to help improve in this world. And a lot of our solutions, a lot of our time goes towards not just being able to benchmark sustainability, but also help our customers reduce their energy footprint, their water footprint, and their natural gas footprint. And so we're able to drive those actionable outcomes with our product. I think the great way to actually showcase how we're doing this is to just jump in and provide a quick little demo. So we've got a couple great new features that we are always innovating. We release updates on a weekly basis, but I want to just showcase two today. One is our portfolio dashboard, which highlights some of the sustainability metrics that we're deriving from all of the data coming in from different shapes and sizes of meters and buildings and whatnot. And then I also want to highlight our new search and explore feature. So this is really putting the knowledge graph in the hands of our users, which is amazing because they're able to get so much out of that. And so let's jump in and take a look. Here we have the WillowTwin user interface, and we're going to take a look at how some of the great technologies underpinning it, such as Azure Digital Twins and all of the IoT products, come together to create these experiences. And so this is the dashboard, which is a summary overview for the entire portfolio. Along the left side here, we can create filters. And so right now we're looking at the entire portfolio, but if you want to look at it on a per building basis, you can do so. And if you want to look at it on a per region or per location basis, can also do that. As we look at the management performance, we can see the overall score, and we can see how each individual building contributes to that overall score. And you can see certain buildings that are performing well with the green indicator, and maybe buildings that aren't performing well that you want to dive into, such as the red indicator. We see at the very bottom other KPIs contributing to this overall performance score, such as how well work orders are being performed according to their SLAs, unplanned work orders, as well as understanding some other key metrics, such as how the team's performing over on the right. We have a nice visual geographic indicator on the upper right here showing where those buildings which are listed are actually located on the map. As we look at the operational dashboard, we can understand how buildings are performing for the operational team. And so again, we've got some key metrics around how energy per square foot is tracking, what your equipment lifecycle risk is, and also how your comfort is for that building. All of these metrics are underpinned by the common data model, which is developed with DTDL and the relationships between the twins. Each of these buildings, in this case, has a unique layout. They have a unique sensor setup. And so you can't just rely on a nice, common, clean infrastructure. So for example, one building's total energy score might need to be calculated by subtracting 1 meter from the other, whereas another building's total energy score might need to be calculated by adding up 3 individual meters because there's 3 separate service entrances. All of that gets loaded into the graph such that these scores can be presented in a nice, consistent manner. Next, diving into energy. So these energy scores, you can see here the total energy for the portfolio. And again, you can look at the outliers in terms of an energy KPI, such as energy per square foot, or even energy per square foot per degree day, to understand how to normalize across different climate areas in your portfolio. And you can see here at the bottom, not only is energy per square foot plotted out, but also what the CO2 score is, and also weighing that against occupancy. So starting to understand how much energy buildings are using per occupant of that building. And you can see here on the bottom right, charting that out, not just in terms of your megawatt or kilowatt hours, but also how it equates to the actual financial aspect. Once we look at that, we can start to dive into occupancy trends. So again, how are the buildings being utilized? And also kind of what the different KPIs we can look at for occupancy, such as energy, air quality, or straight occupancy itself. And again, all of these are able to be filtered on a per building basis. So if we come in here and look at the Central Towers occupancy, you can see how its score relates just for that building, how it's been trending over the last month, and some of the trends you can see whether they're gaining or decreasing. So again, these dashboards are all underpinned by that common foundation with the ontology and being able to relate twins to other twins, even though the buildings themselves are not all set up the same. Another powerful feature of the WillowTwin is starting to understand how you can actually search and explore this knowledge graph. So rather than having to explore data from the business intelligence or analytics layer that we just looked at, how can you actually just start to understand what the different components of your building are and quickly get an answer at your fingertips? And so here I'm going to showcase an example where we're going to start to search for AC or AC units. And so we start to search that knowledge graph. We can filter it by DTDL category, or can also just look at results of hits on twins. And so this case, I've searched for AC. Maybe I'm interested in AC unit 4.2. And so I'm going to pull up all the information that I have about AC 4.2. On the left, you can see how it's been categorized and some key relationships that it has. You can see an overall summary around, maybe its warranty information or the size of it. And also understand at a glance important live data aspects, such as what its key data points are there any open issues or tickets on it. You can also dive into some file documentation around O&M manuals or maybe sequence of operations for that piece of equipment. The really powerful features over here on the right, if I need to understand who its upstream or downstream assets are in terms of how it's being fed, maybe water or air or electricity, or maybe even connected to data, those are all shown here in this relations map, and which is basically just a beautiful representation of the underlying graph that's stored in Azure Digital Twins. I can explore time series for that piece of equipment. And I can even then visualize it in its 3D context. So I can get a quick understanding of where it is placed in the room if I need to do maintenance on that piece of equipment. So a really powerful example here of bringing all the various components of the digital twin, whether it's static information, files, time series, pulling it all together in the context of its relationships.
Rick, that's really nice. I can see lots of improvements since our last video. Thank you so much for the walkthrough of latest features of WillowTwin. I've been hearing a lot and lots of great things about the new Willow rules engine, which is also powered by Azure Digital Twins, Azure Data Explorer. Can you share more about this new engine?
Yeah, we're extremely passionate about some of the outcomes that we're going to be able to drive for our customers with this rules engine. And I think you nailed it. The rules engine is built on that foundation of Azure Digital Twins, leveraging the ontology and the knowledge graph, and then also that Azure Data Explorer to pull in that time series data and process data in real time. So I'd love to just walk through a very tangible example to kind of just showcase one use of the rules engine. And so this is an example about leveraging occupancy sensors, which are typically installed either as IoT devices, or they could be installed as part of a lighting control system required by code in many areas of the world this day. And then the BMS, which controls the temperature in a space. And so what we're going to look to achieve here is these are two disparate systems that typically don't talk to each other in a building, but we're going to leverage the rules engine and the graph to showcase a scenario about how powerful this can be for reducing energy. And so what we have here is when someone leaves a room and the occupancy sensor triggers that there's no one in the room, it changes its status to vacant. That signal gets sent to the WillowTwin. And then ultimately, we want that to be able to send a command to the BMS to relax its set point. So if it's in the cooling season, we'll increase the temperature set point in this example. So the benefit that we're, again, trying to drive here is reduce energy footprint. And you can imagine that applying this through as a common rule across not just an entire building, but an entire portfolio of buildings, millions of square feet, we can drive substantial savings. And so let's dive in a little deeper for how we do this. Without Azure Digital Twins, if I were to try to enable this scenario, it looks something like the left, where you have to sit down and literally do a one-to-one mapping for, hey, what's this occupancy sensor ID here? What's the thermostat ID over here? Let me map the two up and I can enable this scenario. You can get it done, but it's very laborious, tedious, and it doesn't dynamically scale. So if I add or remove a sensor or expand my building, I have to reprogram everything. With Azure Digital Twins and our rules engine, we leverage the graph for what it's really good at, and that's writing a dynamic rule. So we write one rule and traverse the graph. So let's dive in and take a look at how we do that. So this is just a little snippet of our graph. We've got several different types of twins here. In the upper right, we've got twins related to the lighting control system. In the middle, we've got twins related to our HVAC control system. And in the bottom here, we're showing different spatial twins, part of our graph. So we like to think of these as different data sets all overlaid into our graph and with different relationships connecting them. So starting in the upper right here, we've got our occupancy sensor, which changes to vacant. And we're going to write a rule. The first part of our rule says, find the related room. So we traverse the graph until we match on a room. And in this case, we've matched on two rooms, which have just been highlighted here in green. And the next part of our statement in the rule says, for that room, find out which terminal unit conditions it. So we traverse the graph some more, and we find that fan power box, which is conditioning those rooms. Now, this is the part where I like to really highlight the power of the ontology, and which really differentiates Azure Digital Twins and how Willow's leveraging it. Fan power box is a subclass or an extension from the terminal unit family. And so while our rule says terminal unit, it will match on any type of terminal unit. In this case, we're matching on a fan power box. A very powerful way to write a single rule and have it be applied across an entire portfolio, which is really important. And then the last part of the rule is to be able to actually send the command to that unit to adjust its set point. So in this case, we find the zone air temperature set point, and adjust it from 22 to 25C.
I love it. What can I say? And now just to make sure that I didn't miss this, could you please explain me the meaning of the dynamic rules in your title? So what does it mean, dynamic rules?
Yeah, really, that's just my way of kind of indicating that the fact that we are using the graph, and so it's one rule that can dynamically be applied to many different subgraphs. So we like to call them subgraphs where we're going to match on potentially 500 different rooms throughout a building. Again, it's dynamic in the fact that it's one rule, and if you add a room, if you remove a room, that's perfectly okay. It still runs, and it can be applied to 499 or 501 rooms dynamically, as opposed to that hard-coded sort of manual mapping exercise that we saw on the previous slide.
Got it. So if the graph is changing, your rules, the same rules continue to work.
Exactly. Yeah.
Is this rule engine production ready right now so our customers take benefit?
It is. Our customers are getting a lot of benefit already. We're getting some amazing stories coming from our customer success team on the value that it's providing, whether that's quantified in energy savings or improved operational outcomes. It's live and it's ready and being deployed across millions of points that our customers have.
That's really nice. Rick, it's been so great to chat with you today and learn about WillowTwin. It's great to have Willow as a strategic partner with the agility and the ability to move fast and deliver high value to our customers. And I'm looking forward to unlocking more capabilities and seeing where your product goes in the future. This was Willow's tech story for today. See you next time.
Thanks, Alina.
Thank you.